but
fast
it's
forward.
It's up to them.
You
I'll
can
do
take
whatever.
clips. And then when you want to take a record, you push a little button and it puts a timestamp on it, and it auto-fills a certain amount of data, and you add a few to it.
Yeah.
And then when you're done with the dive,
Sure, that's fine.
you push another little button, and it merges
settle
all
out
the
and do it.
temperature and lat and longs and depths and everything else, so you don't enter it yourself.
Wow, that's nice.
It's really cool software that was developed by Brian Schilling of the Monterey Bay Aquarium Research Institute.
Here's a little
yeah, a little
fun sponge, and then another one coming up in Argus view there. Zoom in there, please.
That is a... That is a...
We're going to move to the next one.
We look at the other side? Yeah.
Sorry, Chris. We're just finishing speed moves here, so...
No problem. I think that was
another
Calophacus, and I already tell this is a Bolosoma.
Because of the yellow?
I love that yellow. It's so cool.
Wow,
Bolosoma species B.
What an amazing color.
Oh,
those are cool.
That's a smaller one than
yeah,
the big one that we saw last night.
They can, their morphology can
Bolosoma.
change a little bit here, but yeah.
So a viewer wants to know what is the geological makeup of the seamount we are exploring right now. That's Christy from Virginia.
This particular one is all basalt, you know, with some sediment on top of it. It's all volcanic, because this one was never close to the surface to our knowledge, so there's no old carbonate reef or anything like that on it.
Not a geode.
Not a geode, which is a flat top seamount.
Chris, so we just let the ship finish that move. We're going to just give it a moment for Argus to settle into place, and then we can talk about maybe going directly into the wall and up a little bit to see if we can find that kind of
sweet spot.
Edge spot, yeah.
Okay, great. Thank you. So with the viewer who is asking about the geology, this kind of round, sort of lumpy texture, this is all the result of lava that's erupting out into the sea surface in deep water, and then it forms crusts and forms this toothpastey type flows that start flowing downhill, and that's kind of what you're seeing. It's eroded over millions of years as well, but sometimes you can see very intact what we call pillows, and these are these toothpaste sort of tube-like formations of lava that had erupted and cooled very quickly.
And what it determines their size? Because some of them are small, other ones are bigger.
Just how fast it's erupting, how much volume of lava is coming out at one time. You know, and I've seen enormous pillows. These are pretty small, most of the ones we've seen. Sometimes it comes out as sheets too, rather than just toothpaste.
There's a sponge.
Yeah.
And nothing really weathers this stuff over time. It just is kind of sits there and gets sedimented on, but
yeah.
I like this little shelf. It's kind of cool.
Yeah, whatever. That's probably part of the edge of a sheet flow or something, which I was talking about.
Right.
I think. That would be my guess.
I'd buy that.
Oh, that's sponge. Never mind, Calophacus. That's fine. Oh, there's a shrimp, long-legged shrimp.
We're starting to slow down now. We could have a shrimp zoom.
Now that you're looking directly at that, I don't know if it's worth going up slope because it looks like it's definitely flattened out, yeah.
Okay.
Yeah.
We could
go ahead and zoom in the shrimp.
Down because you're pretty close to the summit already and we're not seeing anything.
Oh, that's where those long
Yeah, fairly close.
Wow, whoops.
Okay, this is Nematocarcinus, and we're not sure of the species. There's a whole bunch of these species. They're all over the place, across the Pacific, quite a few of them.
Okay, come wide, please. Thanks.
They're easy to spot because they have extremely long, tiny,
It's incredible how
Toothpick-like
tiny
legs.
legs, yeah.
Fragile.
It's one of those polyopogon sponges that I think we collected the other day.
That looks more fun.
Oh, we're
Ah.
looking like something's getting a little steeper.
Some potential action here,
Yeah, I
hopefully.
like that spot. That's a nice one.
It just looks like a coral down below the ledge.
Is there something floating in the water? Oh, we just passed it. It was a fish, I think.
Fish
Oh,
on.
I didn't see it.
It went down.
There's something floating in the water and also attached to the ground.
Where?
Oh, one of those giant stalk
Oh.
sponges. Or no,
Yeah,
that's
one of
probably a
the-
coral.
Yeah, one of the
Bamboo
giant
coral?
bamboos.
Yeah.
This looks like it could be a fun little interface area. We got some animals.
Yeah, this
Sticking
looks,
it.
this looks reasonable, and there's less sedimentation here,
Yeah.
too.
Coral on the rock to the left. And so do you want to follow this contour, or what do you think?
Yeah, we're actually starting to see a few things. That's
Nice.
the Ramula gorgia militaris on the left, the sort of gray-colored coral. There's a black coral to the right of that, probably a... Oh,
We got
you
actually
might
a
guess.
bunch of different species of coral. Can you do a half zoom, please? Like right there, yeah, we got 3 species of coral right in that view.
Yeah,
4.
so above it is the Chrysogorgia. And this militaris, this blue one, is a Chrysogorgid. It's in the same family. The red one, hard to see because we're looking right at the plane of the coral.
And a black coral on the top left, I think.
Top left. Very good, yeah. It's something like a
Bathypathes.
Bathypathes-like.
Really
Sure what
tiny.
it is.
We could do a full zoom on that and see what that
Yeah,
pink one
what is that? It's a... Well, it's a corallia, but this is actually Hemicorallia abyssal. I am pretty sure. This tends
Okay,
to be
come
one
wide,
of the
please.
leggier kind of coralliids, and also the branches typically there can be a zigzag in the branches, and then they at the very end of them you have a polyp on either side of the tip of the branch. It's a very characteristic type of arrangement.
It's cool seeing that big long bamboo coral in Argus view, just below Herc.
Yeah.
How are you feeling? Do you feel well settled
I
enough?
think we're definitely settled, yep.
All right, then we can
So.
move it along slow.
A few I was beginning to wonder the whole dive is going to be back like what we were just in.
005.
That sounds right. Yeah,
You
sure.
like? You dig it?
Dig it.
Bridge nav.
You said the top's 2,200 or
In
so?
a 20-meter step, bearing 005.
Something like that. I think that's a little bit deeper than that, but maybe 22.5 or something. Sure. Okay.
We have a question for our pilot or navigator. How is the latitude and longitude of the rover determined, and how precise is the location? What is the margin of error?
Geez, oh man. Well,
Big question.
yeah, so the position of the rover is determined by the USBL, so that is an acoustic system, and that's then translated into, well, it's regional, it's a localized coordinate system that gets translated into latitude and longitude by integrating with the ship's position. I do not know the uncertainty or precision. Trevor, do you?
No,
I don't know.
I don't know. It depends on water depth. And I want to say 1%, 0.5% of water depth.
Oh, fish,
There's
please.
something.
Oh, fish,
there.
fish.
That sounds about right.
Okay, Aaron, you can zoom and keep it in frame, please. Try and get closer.
Oh.
Cool. What do we have?
I'm thinking about it. Well, I have a guess, but then the head didn't quite shape up the way I thought it was going to shape up.
It's impressive he's swimming backwards.
Can you look along the side of it, by any chance?
I can
He's
zoom
turning.
more. I have more.
There, a good close-up of the side. Well, there he goes.
Go away. Hey,
Well,
come
it's
back,
definitely a cusk eel. It's in the, it's in the order Ophidiiformes.
When you're happy for me to zoom, let me know.
Yeah, zoom whenever you want. Yep, no problem.
It's quite a thick head.
Okay, that's better. So this is in the genus, and Ken may disagree, but I think this is in the genus Basozetus. That was a good view of the side of him.
Oh, bye.
Ooh.
I don't think it's the same one that he thought was that
Thanks.
real rare one, but I hope he...
Oh, there's something else floating there.
Yeah, what is
Oh.
that floating?
Whoa,
Oh,
there's another fish.
Oh,
Oh, wow.
creeper.
hi.
Wow.
That's
You can
cool.
zoom at your leisure.
Ooh.
Let's paint him with the
Oh.
lasers really quick, and then I'll turn him back off after.
That's so.
Trying to get the lasers on him. There's 10 centimeters. So that's a large fish. You can turn lasers off again.
Okay.
Some beauty shots.
Is that like a
So this is
macro
actually
day?
this is actually a pretty easy one. This is Coryphaenoides. This is
Coryphaenoides
actually a rat tail. So you have two different
What?
families here. The first one was Basozetus, and this is Coryphaenoides. I don't think I can go further than that. This
That's a
is one of the
huge
biggest
rat
ones
tail.
I've ever seen.
Yeah.
And it's a cool looking one.
How
it's
big?
amazing.
Yeah, how big is it? I wonder what this lasers...
We just had the lasers on it earlier. We'd have to
Like
scale
30
it. It could be nearly, maybe not quite a meter. It's
that-
a big fish. Maybe
Wow.
Mm.
It could be preggers, but I'm not sure. It seems like I got a bit of a swollen abdomen there.
Oop, there's the lasers again. It's definitely over a half meter, maybe
Yeah.
not a full meter. Wow.
Some of the characteristics of this genus, they have long modified pelvic fin filaments. They also have a longer dorsal fin filament. They have very large eyes. They tend to be one of the larger macrurids or rat tails.
What's on his little bottom left? I don't know what you call those, fins or feet or whatever they are. What's that little hanging off thing?
Yeah, those, I think it could be a parasite or something. Possibly some type of a copepod parasite or something. I'm not sure what that is.
Yeah, it does look like it's attached pretty good.
It's something that shouldn't be there.
Poor
How's
guy.
that?
Look at the scales.
He's thick.
So, Kainolu?
Yeah.
That's the first one.
How do you?
It's called a Basozetus.
Basozetus.
So that was the very first one, not the one we're looking at now.
Okay.
And then the one we're looking at now
Thank
is
you.
That one, Coryphaenoides
Coryphaenoides.
longiceros.
It's pretty nice.
Oh yeah, that's a little critter. You can see it's moving around. Its fin.
Just like modeling for us.
All right.
Okay. That's how you spell Coryphaenoides.
That was fun.
And I wouldn't go to
Primitive.
species on it because I don't know them well enough. So
Thank you.
that,
Sure, yeah. Let's do
Bridge
a
nav.
maneuver. Another cucumber.
Another 20 meter step, 005.
Was this the one we tried to slurp and failed at?
I think so.
Looks
Do
like
you
it.
want to try again?
You want to? I'm game.
Bridge nav, hold position.
Sorry.
It's okay.
Slurp away.
Another big one.
So where you can use the lasers to determine the diameter against the diameter of the slurp pipe?
Yes and no. I don't know the diameter of the slurp pipe. 2 inches?
The genus
2 and a
is
bit?
fine, because it's
So
not
5 centimeters?
Longicurus.
It's going to be bigger than the slurp pipe. So other options available to us. I don't know how intact it must be, but it could go into a box.
I think we could try. This could be durable enough to hold up the handling. I don't think it's super gelatinous.
So grab an in-box versus slurp?
Yeah, if he's too big to slurp, then a box could work.
Okay.
One way you could do this, you could sort of slurp his side so he kind of sticks like a suction cup against it, and then release and let him in the box. I've seen that happen before.
Yes, we'll have to use the forward box, and I don't know that I can do that with coral cutters, but I could sure try. But it'd have to be the forward box.
Okay. Oh, then never mind. Let's try to grab him and put him in a side box. I'm not going to do anything to best box. Best
Roger.
boxes.
Okay, we'll go for a grab then.
Okay.
Like getting them for
So
Christmas. Look at that red with the green dots.
Am I going to have to just feather the gripper the whole way?
You can put it on grip force 1, which makes it a lot easier to feather. It will still close all the way, but it'll close very, very slowly and makes it a lot easier. So you can start with doing that. So once you turn on hit the blue button, or blue light button, and then on grip force, second from the bottom on the left, just do 1 or 2 or something. Good. Yep. That is, I mean, this is the mode.
Do you want super wide?
I think it'll be okay.
Can you bump Bubble up so I can see him? Thank you. Perfect.
So when you go for the close, you'll notice that they close a lot slower because there's a lot less force on that joint.
Awesome.
So that's why it's a little easier to feather.
But I shouldn't put it in grip lock then? Oh, I see.
You will have to halt at some point, which ends up being the equivalent of grip lock.
Okay.
So if I would try to grab, actually here's a question for the science row. If we were to grab it at one end or the other, what's the least invasive way if something ends up getting squished?
Can you zoom in on it so we can tell where the mouth is?
Yeah.
Okay, go ahead.
Okay, how about the end that's facing us right now, closest to us?
Closest.
Roger, we'll grab the close end.
Okay.
Do you want it zoomed back out, or you?
Can I get a half zoom?
Okay.
Yeah, thank you. That's really slow.
Yeah, it's very slow. So it makes it easier to feather, but it's also very slow. And if you let go of it, it's going to open full speed, just so you know. So you can feather it open. Yeah, exactly.
Sorry, I feel like are we moving?
Yep.
Hang on. Thanks.
minutes.
No. Yeah.
So when we collect fish, do we slurp or
Fish,
do we collect fish?
we don't often collect fish. It's too hard.
Mm.
Need a power slurper for that.
Do you need me to reposition?
They protest too much.
Mm-hmm.
Why don't you put the grip force on grip force 2?
Chris, what kind of research are they doing with these? What are they looking for?
Well, still trying to figure out if this is the one that we had a request for, because I can't seem to find this in the guide. But it's a comparison.
It's pretty far away, so
between
come full wide, please.
Shallow.
I'm going to just shimmy it forward a bit.
Shallow sea cucumbers versus some deeper ones, different families. So it's very likely that this is going to wind up in the ultra cold freezer. It comes up.
You can call for another zoom if you want it. All right, you got it. That is the way that it's grabbed. I'll follow you around with this too. Let me know when you want sample salvo. Oops, up is down, sorry. And I'm ready to open the box whenever you are. We'll put that in one of the small boxes.
Yes, please.
Okay. And I think they're all open. I forget.
Yeah, they're all open.
Okay. Yeah, Roger. Stand by there. Yeah. Moving, but we're not going to go too far. Okay, ready to open the box. The starboard vertical thruster is secure now. Okay, opening box.
Oops.
Oh, no.
Well, there's little bits of it left in alpha.
And box A.
Remember, as soon as it opens, it's going to get stuck, so you want to kind of feather it to get out of there. So close the jaws again. You got to close the jaws to get out. There you go. Now?
Okay, thank you. Well, I think it's a genetic study, so that
I guess so,
that
yeah.
might work. But you know, some people might think it's easier than it looks, but I'll give you an analogy. One time we were playing a game, it was ping pong, but we had to blind one eye. And so we use our binocular vision to get 3D to play and know where the ball is and hit it. But when you blind one eye, I could barely hit the ball because you have no depth perception.
Makes
that's
sense.
the tricky part of what's going on here. It's really hard to develop that depth perception.
Yep, that's good. All right.
Great, thank you.
Sorry, I smooshed him.
Well, you might have enough in there that's going to work. Well, we'll just have to see when it comes up. But those are not the easiest critters to collect. I'm sorry I put a really tough one on you.
It's all good.
That's also one reason why we slurp those whenever we can.
Totally, yeah.
Because they're hard to grab.
A listener was wondering if a net would be better to collect.
Sure. Yeah.
Possibly, yeah.
But hard to get back out of the net.
Yeah, that's true. They could get stuck in the net.
What was the question?
It was whether a net would work. You know, like a little fish net or something?
Oh, yeah. There's a whole study of soft robotics. That's a whole field of study, is ways to sample these critters without squeezing them with the manip, obviously, but also without bashing them up in a slurp. Some things are too fragile to go through the whole journey of the suction hose.
Was that what Jessica's research
Jessica's does a little bit of that, yeah. She does non-chemical adhesion.
Okay, because we filmed her talking about it, and it sounded really cool, and she was talking about picking up an egg with this suction.
Totally, yeah.
That's amazing.
And for stuff that doesn't suction as well, there's another person I sail with out here that does, like, I don't even know how to describe it. Squishy fingers, I think they call it. They're like soft fingers. They kind of reach around a critter and don't squeeze it, but just kind of caress it. I don't know. I don't know how to describe it, but it's really fascinating.
We have another question here. Have you determined how the metabolism of deep sea life relates to surface? Are deep ocean animals energy conservers? Or do they have rest periods followed by hunting periods?
You want to handle that, Andy?
Yeah,
that's a very good question. The problem is I don't know that at all. It's a very good question. My sense, let's see. My sense is that the metabolic rate is lower than a lot of the animals at the surface, partially because of the very cold temperature. They tend to be a little slower and more sluggish. Not all of them, though. And then I think they do have rest periods. There's a lot of sea cucumbers that'll move and start swimming for quite a while, and then they'll settle back down and sit on the bottom for a while. It looks like that could be your equivalent of a rest period. And then they can try to pull up some detritus again, and then they'll pick up and swim off somewhere.
Now that's geology.
Yeah, it is.
That's geology.
But anyway, that's a very good question. And I'm afraid I can't give you a very good answer. I'm sorry.
Thank you. Thank you for the question and the answer.
I have a question for the ROV pilots. How do they test the manipulators when, like, on land if they're going to be under so much pressure? Does it make a difference? That's probably a dumb question, but.
Oh, no such thing as a dumb question. We test the manipulator before every dive. And the cool part about it is there's no air inside it.
No, that's
it's all full of oil and metal.
I suspected somebody was behind me. Okay.
It's all full of oil and metal, which doesn't compress. Well, technically it does, but we'll say it doesn't compress under the pressure of the seawater. So it behaves very, very similarly to how it does on land with no pressure.
Oh, that's really cool.
So some of the places that have the electronics in the arm, they're full of oil. It is not hydraulic oil. It's not used for the hydraulic pressures in the same way a crane or whatever else has hydraulic oil. This is just used to push back against the pressure of the ocean.
Okay. So it's almost like a place filler.
Exactly. It's exactly like a place filler, yeah.
Cool, thank you.
Yeah.
Okay, so we're going to do a change of watch back here in science and probably up front. And Dr. Beth Orcutt is here. And I hope the viewers are going to give her just as tough of questions as they gave me. I'll give you a clue. But anyway,
That's
I'm going to turn it over to Beth. We're going to all switch out. And thank you very much. There's going to be a little bit of a pause. Stay tuned. And then you're going to have a whole bunch of new voices that you're going to be hearing for another 4 hours or so. We'll talk to you later.
Okay. Oh, that's not right enough. How are you doing on this wall here? All right. Check. Oh, I got a lot of side tone. Gotta change that. Check, 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 check. There we go. Okay.
Good afternoon, control pan.
Hello.
Good afternoon.
Afternoon.
Evening? Day? Light? I don't know.
Who's to say?
Okay. This is Beth. Hi. One of the science leads for this ship's dive, part of the dive. And there you are. As we have been traditionally doing at the start of a shift, we're going to go radio silent for a few moments to conduct a private ceremonial protocol to acknowledge and honor the biocultural resources that are present and that we are interacting with and impacting. We'll be back on audio shortly. Everybody, if you could please mute yourself.
Hello.
All right, welcome back, everyone. Rennie, can I get an update on how we're doing with ship move, any of that kind of stuff I should be aware of?
Sure. We're currently stationary. Just resetting some gains here. If you take a look at high pack, from what I understand, and maybe they passed this along to you as well, we're kind of at the top bit of, so Herc is facing roughly west, and any further up seems to flatten out quite a bit, which matches our contour lines here. They spoke of walls, steep walls. I don't know if it was just where they were over here, or maybe we've ascended too far and would need to back down to the east in order to reacquire them. That was kind of the understanding I had. It looks like as far as progress along the dive track, we're a little more than halfway along from the proposed track, which of course has a lot of leeway. We could do whatever,
over the other side,
go around or whatever. Yeah.
Okay. Thank you for that. Yeah, so then, Jess, what would be your preferred move? Would it be to like lateral right or north, or would it be to come down and then move over?
Either way, honestly, or whatever gets you the best signs. So lateral movements are generally fine, and we'll follow contours as appropriate.
Okay. All right, then yeah, let's try to keep moving north along whatever contour gives us some nice wall action.
Okay.
And kind of how it looks.
All right, why don't I do a 50-meter step, kind of, if you look at the angle, we'll back up a bit and still be moving north. So Jess, we may be, as we back off, we'll just descend until we acquire what we're looking at.
Sure.
Okay.
So the general direction we'll be moving, Argus is 0, 1, 0, and so you may want to be perpendicular to that, but we'll actually call in like 0, 3, 5 to back off a bit.
Roger. Sounds good, Rennie.
All right, we'll start with 50 and then probably move north after that.
Roger.
Thanks for joining us this evening. And for those who are commenting that your video feed at home is struggling, I am so sorry for that. We are not seeing it on our end, but we are hearing that from at least a couple folks at home.
Yeah, I'm also seeing that in the science chat.
Any advice, Jeff?
Might just be the satellite.
Well, probably, well, I don't know. We're not moving that much, and it's rattle somebody's cage at URI at the Interspace Center and see what they're seeing. So,
Yeah, we passed this along to our superiors. Thanks for...
The problems leaving here are fine. Sorry, bad joke.
Well, thanks for tuning in, even if the video quality isn't its typical amazingness. It's a pleasure to have everyone joining us from all over the world to explore this unnamed seamount. It was mapped in high resolution for the first time today.
Yeah, and we're coming in after the 4 to 8 watch and the launch. So we get a full 4 hours here of exploration on the seafloor. Similar to other dives that we've had this week, the objectives are really going to be to survey and characterize the geologic region here, potentially sampling some of the rocks. And then we are, of course, really going to be focusing on diversity of coral species as well. We've seen some cool things tonight.
And sponges.
And sponge. Don't forget the
Don't forget
Some cool things and sponges.
Sorry, Chris.
Actually, I caught a few moments of the video earlier, and there were some great sponges.
Yeah, interesting sponges, also some tumbling snails.
Fish.
What made them tumbling snails?
What's that?
What made them tumbling snails? Are they?
They were like, we're getting out of here, and started tumbling down the side of the mountain. And then when they reached wherever they wanted to go, they got their foot to stick back on the wall.
Very cool. Good form of transportation.
Yeah, and even though we haven't spotted a lot of coral on this dive yet, which we have seen some evidence of life up here on the surface of the ocean. When we started the dive, right, there were a couple whales sighted.
Yeah, they are ID'd as fin whales, second largest species of whale in the world. And yeah, there's been quite a bit of activity at the surface today. If you caught the tail end of our dive this morning, there were a number of oceanic white-tip sharks. And they circled for quite a while, interested in those ROVs just about 2 feet from the surface.
Also saw some mahi-mahi.
Did you see them?
I saw one, yes. I heard others say they saw others, but I at least saw one with my own eyes.
Potentially something attracting them to this region.
Yeah, that's what I was thinking. There might be something more down here, but who knows? Maybe they're. We'll find them on the next dive at the Don Quixote Seamount. Who knows?
So we're about 2,300, 77 meters.
Yeah.
And we are descending down a little bit.
A little bit slowly, yeah.
What's kind of the final range for this dive today?
The dive plan actually suggested kind of just following a contour instead of going up and down. So where are we at? So we're ranging from kind of 2,600 to 2,100. This feature is not very tall. So already at not even 2,300 meters, they were kind of coming to what looked like a plateau where we just were. Maybe it'll get a little shallower up ahead.
Someone asked for the full underwater weather report. I think it's about 1.8 degrees and 100% humidity.
And for those of us that might just be joining us for the first time today, we are currently in the Papahānaumokuākea Marine National Monument. Very culturally significant area. One of the interesting things about the monument is that there are a lot of conversations that happen with the Native Hawaiian community to ensure that cultural protocols, traditions, and histories are held up to the same standard, if not, well, at least on the same standing as like any of the other like safety or like scientific protocols on here. And so it's really been a pleasure to have discussions with the science team and to just sort of navigate that space while we're going through these dives. So I really appreciate that. If anybody would like a little bit more cultural context into the monument and just a general place where the other expeditions in the area will be taking place, please feel free to go to or you can just search Papahānaumokuākea on Google. But there are two specific sites. One is papahānaumokuākea.gov that is arranged by NOAA, and then there's another site with the Office of Hawaiian Affairs where you can also get some historical context, and then an introductory cultural briefing video, as well as some of the original compositions that were composed for the place itself, and also some of the protocols in which we're employing on the voyages. So go check it out, gang, if you guys got a little bit of time. Mahalo.
Yeah, thank you for that reminder.
Yeah.
Thanks, Camille. In fact, viewers writing in that us opening and grounding ourselves at the start of each watch has triggered or reminded them of an act from years ago when working with the Aboriginal people of Northern Canada, and they had a morning hunting prayer. And so every time we go silent, they are also revisiting their practice as well. So thank you for the enrichment.
Yeah, that's an interesting standpoint, right? Like being able to sort. I believe that different cultures have different ways of centering themselves and crafting that intentional focus to be able to go through with this work. So I think that it's really awesome that various communities being able to set that intention for themselves in those spaces, no matter what the context may be, is very important. So thank you for that. Thank you for that. For sharing that, and we hope that if there are any other indigenous cultures out there that feel like sharing a bit of whatever you feel is appropriate, I would say in this context, please feel free to do so. I think that it's a very important thing to be said in terms of how we look at our own management here within Hawaii, and how we might be able to use these expeditions as a platform to discuss those with other indigenous communities around the world as well.
Yeah, we really hope to model something that can be translated in other places as well.
Yeah, and as you mentioned that it's not just for this cruise, this expedition, but actually a series of expeditions that are happening within the monument, and a goal of linking those together as one story, which is, for me as a scientist participating, it also helps me to put my research interests into the perspective of a broader family of research happening here. So that's another element that I appreciate of how we're approaching this, and bringing in culture to our scientific approaches.
And thank you for that. That's an amazing, manao or like a thing to bring up, but I would argue also too that there's definitely a culture to science, but the way that we're able to sort of translate and negotiate those ways that we inform each other's practices are very valuable experiences. Like, for instance, myself, sorry, probably.
Sorry, small inside joke happening here.
Yeah.
If I can just quickly interrupt,
yeah.
The ship move is complete.
Oh, already, okay.
And Argus has still got a little bit to go, but while we're there, do we want to continue on that? I don't see anything wall-like. The steepest thing was where we just were, and that kind of seemed to be flattening out.
Yeah.
So we could continue down and see if we acquire anything. Still on the 035, slightly downslope, slightly north.
Yeah, let's keep going down slope just a little bit.
Sure.
We'll stay on this trajectory, and then if it does not yield much biology excitement, then maybe we'll start yo-yoing back up the cliff.
Sounds good. I'll just do another 50.
Okay, thank you, Ryan. Sorry that you were interrupted.
Oh, no, all good. This is a perfect example, right? Like, we have, I in my own ways am very limited in what I can interpret or what I'm learning to, and so just being able to see the various specialties that come into play in order to create a multidimensional and multidisciplinary approach to this type of work is very enriching. So I encourage, if any of our young listeners are out there listening to these conversations and watching these expeditions, I implore you to, think about your families, think about the cultural backgrounds that you come from in your communities, and to take that along with you on these things. It's a very, very enriching experience to have a microcosm of communities on one vessel towards a collective goal, and being able to have these constructive conversations towards not only perpetuating, but also maybe in the works of creating best management practices in context of the place, community, and culture.
Yeah, I'm definitely learning a lot that I am excited to bring back to the community that I work with in Maine, in terms of how we can do science in a new and enriched way.
Mm-hmm. And I'm equally interested in the science of a lot of things that maybe I couldn't contextualize otherwise. So it's really awesome.
Just to reiterate again, thank you everyone for describing in detail what you're seeing on your screens at home. It does sound like this is absolutely a satellite or potentially transmission issue. So apologies for the issues you're experiencing in video and audio. We have passed this along and hope it can be resolved at some point.
Good news is you're not missing a whole lot in terms of biology, but if you're a rock lover, then that's pretty sad that your view is very pixelated.
Yeah, I guess we just have to describe it in detail, Beth. What are we looking at here?
Oh, yeah, okay, I set myself up for that one.
How many rocks are in front of us right now?
Yeah, okay, that sounds like a road trip game. Yeah, so we are currently, Jeff, do you mind bringing, is Jeff there? Yeah, would you mind putting high pack on one of the feeds, please, in case people can see something? Yeah, thank you, and thank you for zooming out, Rennie. So we're currently on a relatively small seamount feature that looks like it kind of has two lobes to it, kind of a north-northeast, south-southwest orientation. And we are moving up the eastern side of that feature. We started the dive around, I believe, 2,600 meters or so, and have been slowly working our way along the flank of the seamount, between about 2,600 and 2,300 meters, looking for signs of life. And so far there's been some surprises in the sense that we haven't seen a lot of coral, which we were kind of expecting, or that was one of the things we were on the look for. But what we are seeing is the bare rock of the seamount. This area looks a little bit more sedimented than some of the sites that we have done dives on previously. So whether that's because the water column above the seamount is slightly more productive, and so there's a little bit more detritus running down, or if the current is just not as strong here, so it hasn't scoured away the sediment. It's kind of hard to tell. But it does, what we're looking at does seem to be kind of the original feature. We're not looking at talus at this point. So we've got some evidence of kind of a thin sheet flow with some extrusive basalts. That's kind of what we're seeing. So shades of black and gray and brown is what it looks like. But not much life attached to these rocks. I think there's maybe a dead sponge there at the bottom of the screen.
Yeah. It's the stalk of a sponge, yeah.
Yeah.
And is everything we're looking at volcanic? Someone would like to know.
Yes, yeah. So the assumption is that this seamount formed over a mid-plate hotspot where you have both intrusive and extrusive magmatic processes. So unlike other volcanoes that you might find elsewhere in the world that are found on ridge axes, where two ocean plates are pulling apart or being pulled apart by subduction on the other end, this is thought to be a different style of volcanism, but the rocks we will be collecting will actually help us figure that out, what the origin was like, what the magma was like. So far, earlier in the dive, I think they picked up 2 rocks for geochemical and age dating analyses. We haven't yet picked up any rocks for our other